Okay, so we've looked at experimental probability and theoretical probability. And in case we don't remember, there are two different things. So experimental probability means something we've actually looked at before, we've seen, we've experienced, we've observed. And theoretical probability means something that we predict might occur. We don't know, we're just predicting, we're calculating. So for instance, if we're going to flip a coin, we know that theoretical probability landing on heads is the number of expected successful outcomes. It's just another way of saying number of expected heads over the number of possible outcomes. When you flip a coin, there are two sides, so there are two possible outcomes. So the theoretical probability of flipping a head is 1 over 2, which we can also expect 50%. Simple stuff, right? Okay. Now, 2 classes ago we did experimental probability, and we rolled dice and recorded what we did. And what we did, and what we came up with when we were rolling our dice, was not always exactly what we would expect. For instance, we might have gotten, in 6 we expect to get 1 of each number, but we might have gotten 2 or even 3 of the same number. So quite often experimental probability is not exactly what you would expect to be. And the nice thing for us is that real life situations can be simulated by probability experiments. So I could sit around all day flipping coins, which, maybe I would enjoy doing, but you're not like me and you don't want to do that. We can use a computer or calculator that will simulate flipping a coin. Here I've got a website up that flips imaginary coins, and I'm going to flip 10 imaginary pennies, and the computer will completely randomly decide whether it will be heads or tails. 50% chance for each coin that it will be one or the other. And we're going to keep track of how many we get. With our first flip, we end up with 1, 2, 3, 4, 5, 6 heads. So let's create a table. Tables are usually pretty useful for this kind of thing. Let's create a table where we can record our results here. And we'll make it, look at this. Okay. So the first thing we're going to record in our table are the number of trials. If we know just how many times we try something, that's why it's called trials. And our successful outcome we're looking for is the number of heads that show up. So the number of heads that show up, you might already notice, is the experimental probability for that particular trial. The average number of heads is going to also be the experimental probability, but it's going to be an average of all flips so far. You'll see what I mean once we get going here. So we've got 7 trials to put in. So on our first one we got 6 heads. So number of heads, 6. So far our average is going to be 6. Let's make this table manageable here. Okay. Okay, let's do another roll. This time we've got 1, 2, 3, 4, 5, 6, 7 heads. That's probably not what you'd expect, right? You'd expect 5 if it's 50% chance. So now our average is going to change. So how do we discover what the average is of 2 separate trials? Well, in each trial we flipped 10 coins, so total 20 coins so far, and we've gotten 13 heads. So that's our experimental probability, 13 over 20. And then you also have to consider that we've done 2 trials. So we're going to also divide it by 2. We're going to end with an average of 6.5 out of 10. So far, experimental probability is averaging 6.5 heads out of 10. Let's do a couple more rolls. So we've got only 2 heads this time. Well, that's going to change average quite a bit. Now we're at 15 out of 30, which is actually an average of exactly 5. And isn't that exactly what you would expect when you flip 10 coins to get 5 of each kind? We've gotten 4, and then we'll do one more roll. And we've gotten 4 again. So 4, oops, and 4, and 2 more rolls. Got 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. Okay, so on our 4th trial, we've now flipped 40 coins, and we've gotten 19. So I'm going to do a little bit of quick calculating here. 19 heads out of 40 is 4.75. That's our average experimental probability so far. And we've got 23 out of 50. 4.6. And 28 out of 50. Oh no, that should be 60. We're at 4.7. Now we're at 34 out of 70. We're at 4.9 approximately. So we started off at about 6 or 7 heads out of 10, which is a lot more than you'd expect, right, when you flip a coin. And as we get further and further along in our trials, our average experimental probability closer and closer to 5. And actually, when you do a simulation like this with experimental probability, you'll find that the experimental probability always gets closer and closer to the theoretical probability. And I can prove this with the graph. So let's try graphing this. So if we're to do a rough graph here, ooh, that's really rough. Let's try another one. Insert a line. Okay. Okay. Okay, so here we go. We've got a rough graph going on here. Now on the axis, we will do number of trials. And on the y-axis, we will have our average number of heads, which we know is experimental probability, right? So here we can have 0, 1, 2, 3, 4, 5, 6, 7. And our average, we can start, well, let's just do it like this. 2, 4, 6, 8, 10. Now we could never have less than 0, because you can't have less than 0 out of 10, and you can't have more than 10 out of 10. Our highest here will be 10. We could get 10 out of 10 every time. It is impossible, but will it happen? Probably not, right? The probability is that that will not happen. So on our first flip of 10 coins, we got 6. Our average right then was 6. On our second, we got 7. And then we'll just graph all of these numbers here. And then we got a 2, and a 4, and another 4, and a 5, and a 6. So it's kind of all over the map. However, if we graph the average, it looks like a little bit more of a pattern. So the average starts at 6, then it's about 6.5, then it's actually exactly 5, and then it's a little bit lower than that, and a little bit lower, and it's back up to 4.7, and and then it's almost at 5 again. So if you look closely here, you can see that there's more or less a straight line here through the average experimental probability. And we get closer and closer to what we'd expect. Now, if I was to ask you, if you flipped 70 coins like we did, what would you expect to get? You would expect to get half of that. Okay, you would expect your average number of heads out of 10 to be 5. So we can graph that like this. It's a straight line straight across here at 5. And if you look here at our average experimental probability, it gets closer and closer to 5 the more experiments we do. If we were to do 1,000 experiments, you'd see average pretty much almost exactly at 5. That's what's going to happen when we do this. Now, if you remember from the last video, I said that experimental probability and theoretical probability, even though they're different, they're very related. And quite simply, it just means that what we have seen and observed in the past helps us to predict the future. The more we observe, the more we're able to predict what might happen in the future, in theory. Okay, so the theoretical probability and the experimental probability are not the same thing, but the more trials we do of an experiment, the closer we get to the theoretical probability. Or that's the way it's supposed to work. Of course, it doesn't always work that way. And that's about all we have for today.